Now let's put what we have learned so far into practice by going over some few examples. So let's begin with number 1. A chord of a circle is 12 cm long. The radius of the circle is 10 cm. Calculate the distance of the midpoint of the chord from the center of the circle. So for easy understanding, let's begin with the picture. So let's consider a circle. Okay, then let's consider a chord. So for me, I'm going to let my chord to be somewhere around here. So if this is the chord, let's say the chord is 12 cm long, which means the distance from this point, okay, to this point, which is to the other edge of the chord, is simply 12 centimeter. So that's 12 centimeter. Perfect. Now, the radius of the chord or the radius of the circle is 10 centimeter, which implies that if this is the center of the circle, then a straight line drawn from that center to the edge of the circle, which will meet the chord together at one edge of the circle, then that radius will be 10 centimeter. Now, the question was to determine the distance of the midpoint of the chord. Now, let the midpoint of the chord be somewhere around there. Okay, so I'm going to represent that with M. So we want the distance of the midpoint of the chord from the center of the circle, which implies that this is the distance that we need. Our goal is to determine that distance x. I'm just going to represent it with x. Okay, perfect. Now, what should we do? How can we determine x? Now, don't forget, from the theorem we stated in the physical video, whenever a straight line is drawn from the center of a circle to bisect the chord, then that straight line will be at a right angle to the chord, which means that this triangle formed will be a right angle triangle. And since it bisects the opposite side of that right angle triangle, which is the value of x, since it bisects the chord, it means it will split the distance of the chord into 2 equal halves, which implies that from M to this point will simply be nothing but 6 centimeter. Okay, good. So what I'm going to do right now is that I'm going to bring out the right angle triangle. So the hypotenuse turns out to be 10 centimeter. Now we have the adjacent to be 6 centimeter, and our goal is to determine x, which turns out to be the opposite of the right angle triangle, which is actually what we are looking for, because it turns out to be the distance of the midpoint of the chord from the center of the circle. So from Pythagoras' theorem, the square of the hypotenuse is simply equals to the sum of the square of the opposite and the adjacent. Okay, so that's Pythagoras' theorem. Now, since the hypotenuse is 10, so therefore we are having 10 squared to now be equals. The opposite is what we are looking for, so we represent that with x squared plus the adjacent is given to be 6, and we have 6 squared. So let's simplify that forward. So I'm going to get rid of the circle right now, sorry, of the triangle. So therefore we now have 10 squared is 100, and this is equals to x squared plus 36, 6 squared is 36. So what I'm going to do is to subtract 36 from both sides, and we have 100 minus 36 equals to x squared. So what is 100 minus 36? You notice that that is equals to 64 and equals to x squared. Now we are taking the root of both sides, and eventually we have x to be equals to square root of 64, which is equals to plus or minus 8. So we are just going to go for 8. Perfect. So therefore, the distance of the midpoint of the chord from the center of the circle is simply 8. And that is how to deal with problems involving the theorem we discussed earlier in the physical video. Now, for easy understanding, let's consider more examples. Example number 2. The distance of a chord of a circle of radius 5 cm from the center of the circle is 4 cm. Calculate the length of the chord. Please, I would recommend you take your time, read the question, digest it, and know the quantity that is given to you. Is it a chord? Is it a radius? Or is it the distance of the midpoint of the chord from the center of the circle? Because this question, in one way or the other, is a little bit similar to the one we did earlier, but it's different entirely. So let's begin with visual illustrations. So let's consider a circle. So this time around, okay, let me select my radius to be at the same place. Okay, my radius can be anywhere. Perfect. Now, if this is the center of the circle, okay, let me consider. If this is the center of the circle, then the straight line drawn from the center to the edge of the circle is simply the radius. Now they said the distance of a chord of a circle, that is the distance of this chord of this circle, of radius 5 centimeter, which means that the radius of that circle is 5 centimeter. The distance of that chord from the center of the circle is 4 centimeter, which means the distance, the space, the region between the center of the circle and the chord itself is simply 4 centimeter, which is exactly the distance of the midpoint of the chord from the center of the circle. So I'm just going to represent that with a blue line. So that's simply 4 centimeter. 4 centimeter. Good. The question is to determine the length of the chord. So just like before, let's try to bring out the right angle triangle. Since we know that this line in blue color has already split the chord into 2 equal halves. And not just that, it's bisect the chord so that it's at the right angle to the chord. So we are just going to bring this out. Don't forget, if from here to here, if we represent it as x, then definitely the length of the chord will be equal to 2x. Why? Because from this point to this point will be nothing but x as well. Since we know that that blue line has already split that entire chord into 2 equal halves. So if one part is x, the other part will also be x. And all combined together gives us the length of the chord. Hope you got that. So now let's determine x first. Okay. Now, what I'm going to do is to bring out the triangle. So let's bring out the triangle. So we have the hypotenuse to be 5 centimeter, the adjacent is x, and the opposite 4 centimeter. So just like before, let's apply the Pythagoras theorem. Okay, it's important to always write the formula as there is always mark attached to it. Okay, in all aspects. Anything that involves formulas, always write it in your exam or test. So we have opposite squared plus adjacent squared. So now hypotenuse is still 5 squared. Then the opposite this time around is 4 squared, and the adjacent is unknown, x squared. So 5 squared is 25, which is 5 times 5, and 4 times 4 is 16, and we are adding that to x squared. Now subtracting 16 from both sides, we have 25 minus 16 to be equals to x squared, as these cancels out. Okay, perfect. Now let me get rid of this to have enough space. So continue, we have 25 minus 16, that results in 9, and that is equal to x squared. Taking the root of both sides, x becomes plus or minus 3. And eventually, we are going to go for 3, plus 3. So therefore, x is 3. If x is 3, then the length of chord will simply be equal to 2 times 3, which is simply 6 centimeter. And that is how to determine the length of the chord, given the distance between the center of the circle and the chord itself, likewise the radius. So that's it. Now let's consider example number 3. By the way, feel free to pause the video and figure this out yourself. Also, if you are enjoying the video, feel free to subscribe to the channel. And also, you can give it a like. Thank you. Now, on to the question. An isosceles triangle ABC has its vertices on a circle. If line AB is equal to 13 centimeter, BC is equal to 13 centimeter, and AC is equal to 13 centimeter, calculate the height BM of the triangle and hence determine the radius of the circle. So, just like before, let's begin by drawing a picture. So, this is our circle. Inside the circle, we have an isosceles triangle. So, let me subtend an isosceles triangle inside the circle. Now, I'm not just drawing the triangle anyhow. I'm drawing it according to the information provided. Because from the question, they make it known to us that the triangle is such that its vertices touches the circle. Okay, the vertices is on the circle. So therefore, the vertices of the triangle will be at the circumference of the circle. That is, will be all at the edge of the circle. Perfect. So right now, this is our triangle. So now let's label our triangle. So let this be A. Oops. This is A, and this is B, and this is C. So according to the question, AB is 13 centimeter, which means this line is 13 centimeter. Perfect. Also, BC is 13 centimeter. Definitely, they have to be the same because they are isosceles. So, the adjacent side must be the same. Perfect. Now, they said AC is 10 centimeter. AC is 10 centimeter. The goal is to calculate the height BM of the triangle. So let M be the midpoint of line AC. So I'm just going to subtend that as somewhere around this region, M. So that will be BM. We are looking for BM, which is the height of the triangle. So let me put that in blue color so you can quickly identify that. So that's our goal. Our goal is to determine height BM. Okay, let's do that again. Not that really straight enough. Perfect. So the goal is to determine BM. Now, what do you think we can do to determine BM? Don't forget, if BM is the height of the triangle, and the triangle is inside a circle, then the height would have been drawn in such a way that it's going to pass through the center of the circle. And not just only that, the height of the triangle tends to split the base distance into two curves because it tends to tally with the theorem we stated. As a line drawn from the center of the circle to a chord, that it will bisect the chord and it will be at the right angle of the chord. So therefore, this blue line would have passed through the center of the circle if we assume the center of the circle is somewhere around this region. Okay, that is in blue color. So that's definitely AC has been split into two, which means MC will be 5 centimeter. Now we can bring out triangle MBC, which is this one. Perfect. So now bringing out triangle MBC is what we have. So we have M right here, B is here, and C is here. So BC is given to us as 13 centimeter. Now we have MC, we got that to be 5 centimeter. Now we can determine MB or BM. So BM squared will be equals to 13 squared minus 5 squared. So I've done the straight substitutions, okay? We have been using the formula for over 2 different examples now, so you should have been used to it. Okay, I've used the Pythagoras theorem, then I've simplified, I've solved for BM. Okay, 13 squared will be equal to BM squared plus 5 squared. So I tend to solve for BM and have 13 squared minus 5 squared. Okay, perfect. Now we have BM squared to be equals to 13 squared is 169, and this is 25. Now subtracting them, we have 144. So we have BM squared to be equal to 144. So taking the root of both sides, BM becomes 12. Let's stick with the positive part of it. That will be the best one. Perfect. So now that we have the height of the triangle, how can we determine the radius of the circle? So let's get rid of some stuff to have enough space for that. Now, please, students, or whoever is watching, I want you to listen to me closely. Now, from the theorem, which says that whenever a line is drawn from the center of a circle to bisect a chord, that line will be at a right angle to the chord. So, which means if this is the center of the circle and we draw a straight line to bisect chord BC, as you can see, BC is also a chord. That line will be at a right angle to BC. So what I'm going to do is I'm going to draw a line. Let me put it in white color. A straight line to bisect BC. Now we said that line will be at a right angle to what? To BC. So this is the right angle, showing right here. Perfect. Now let's bring out that triangle BMBC back. Okay, if we bring it out back and bring it out. Now we have this to be the center of the circle. Okay, and we say we have a line right here. Now this entirely from this region to this region, that is 13 centimeter. Okay, now we have this of 5 centimeter. So we have NBC. Now don't forget, this is a right angle, and this is also a right angle. Incredible. Now you can clearly see that we now have two triangles that are similar, that are embedded together, that are conjoined together. The first one, if this point, let's assume this point is D, then the first triangle is triangle OBD, which is the smaller one on top, and the bigger one is triangle MBC. Perfect. Now, since they are similar, you can clearly see that they are similar. Now, you might be wondering, why are they similar? You can clearly see that they shared angle B together. And once we have a particular shape that shares something in common, and they are similar shapes, like they are shapes that looks alike, then we say they are similar, which means the properties of similarity shapes can simply comply with them. Okay. So now, what says the similarity property? The similarity property says that the ratio of the corresponding sides of those shapes will be the same. Don't forget, this is 5, right? Now, our goal is to determine this distance, x. Because if it turns out to be the radius of that circle, as you can see, it's coming from the edge of the circle, it's coming from the circumference of the circle, and it's stopped at the center of the circle, which is here. Okay, we are not considering this one because that one is not up to the radius, because it doesn't reach the circumference of the circle. Okay, so that's it. Now, the reason why this one is up to the radius is because the line that we form right here is from the center of the circle, and it tends to bisect 13 centimeter. Are we together? It tends to bisect line BC. So that is why it has to be considered as the radius. Because whenever a line, the distance, like with the example we have been doing so far, if you don't forget, when we have a chord, when it's bisected, there's a distance between it from the center of the circle, right, like here, to the midpoint of the chord. Then any line that will be from the center of the circle to the edge or to the vertex or to one end of the chord is always a radius. Now you can see that this is the chord BC. Okay, now this is the distance of the chord from the center of the circle, and you can clearly see that this blue line is now coming from the center of the circle to the end point of the chord. So that's another reason why OB is the radius of the circle. So our goal is to determine OB. Okay, how do we get that? So how can we determine OB? We said the ratio of the corresponding side of those triangles will be the same. So since OD has bisected 13, this point will be 6.5 centimeter, and this will also be 6.5 centimeter. Okay, so therefore we can now determine the value of x by setting up the proportion. So I'm using hypotenuse to hypotenuse, then opposite to opposite. So we are having 6.5 over x. Okay, I'm taking the smaller triangle first. I'm taking the hypotenuse side divided by the ratio of the corresponding side. Don't forget. Okay, now this will be equal to that of the bigger one. The bigger one, its hypotenuse side is 13. Okay, I hope you are following. 13 divided by then sides right here is the height that we got earlier, and we got the height to be 12. Don't forget, BM is the height of the bigger triangle, MBC. So we have that to be what's it called? 12. So the goal is just to cross multiply and have the value of x. Okay, please, I hope you got this. If you have any questions, let me know in the comment section below. So by cross multiplying, we have 13x to be equals to 6.5 times 12. So if we do the math, 6.5 times 12, So we have 78. So let me put that at this middle. Okay, we use blue color. So we have 13x equals to 78. Perfect. Now we divide through by 13. Then we eventually have the value of x to be equals to 78 over 13. Then we have that to be equal to 6. So the radius of the circle is equal to 6 centimeters. And that is how to find the radius of the circle. I hope you find it helpful. Thanks for watching. So let's consider one more example for better understanding so that you'll be able to handle any problem involving the theorem we stated. Example number 4. So feel free to pause the video and figure this one out yourself. Make use of the knowledge you have learned from the previous examples and figure this out. Okay, after you have your solution, you can pause it to see if you have it right or not. Two parallel chords lie on the opposite side of the circle on the opposite side of the center of a circle of radius 13 centimeter. Their lengths are 10 centimeter and 24 centimeter. What is the distance between the two chords? Okay, so first let's try and digest the question and know where we are going. What exactly are we required to find? To figure that out, to investigate that, let's consider a visual illustration. So we are considering a circle. Let's be bigger this time around, okay? Because we are considering two different chords, okay? Perfect. Now, the two chords are opposite to themselves. So let's assume this is the center of the circle, okay? Oops. This is the center of the circle. Is it two parallel chords lie on the opposite side of the center of the circle, okay? On the opposite side of the center of the circle. I hope you get what I mean by that, okay? On the opposite side of the center, this is one opposite side, and this is another one, okay? Those are where the chords will be. Perfect. So let my first chord be at this point, and I would want that to be the 10 centimeter. If it is 10 centimeter, that means it will be longer like that of the 24 centimeter. So then bring it a little bit upward to a little bit here. Perfect. Okay, good. Now let's consider that of the second one, the 24 centimeter. That one will be a little bit longer, so I'm moving that one a little bit upward. Okay, as you can see, it's longer than the one in blue color. Perfect. Now we have the two chords that are opposite to the center of the circle. Now the radius of the circle is 13 centimeter, regardless of where the chords are subtended. Once a line is drawn from the center of the circle to one end point of the chord, that line will still remain unchanged in terms of magnitude. It will still be the radius. So therefore, a straight line from the center of the circle to this end is still 13 centimeter, and it still remains 13 centimeter to that of the blue color or the blue line. Okay, perfect. So therefore, we have 13 centimeter to be the same. 13 centimeter. Perfect. Now the goal is to determine the distance, or yes, we should determine the distance between the two chords. We need the distance between the two chords. As you can see, the distance between the two chords is this. Okay, that's the distance between two chords. Okay, now how can we determine that distance? Well, what I would suggest doing is let's determine the distance between the center of the circle and the chord in blue. Likewise, the distance between the center of the circle and the chord in white. And after that, we combine them together, and that will provide the distance between the two chords. And that's it. So, how can we do that? Chord in blue color is given as 10 centimeter. And since we have a line that bisects it, then it means this will be 5. Okay, I will consider this will be 5. Okay, I don't need that. Let me just get it. So that's the only one I need. Now the chord in white is 24 centimeter. Since this line has bisected, okay, then it means let me do it this way. I want you to get the concept. Okay, let me use brown. Okay, brown. So the distance between the center of the circle and the chord in white is the line in brown color. Okay, perfect. It's a line in brown color. Okay, you should be able to differentiate it now. And don't forget, now the distance that we're looking for, the entire distance between the two could be the one in brown color plus the one in white color. So that will give us this sum we are looking for. Okay, perfect. So let's continue. Okay, I just did that so you can get what I'm saying makes sense. Okay, now to determine the distance in white color, this distance. Okay, the triangle looks like this. Perfect. So we need this x. This is 5 and this is 13. So from Pythagoras theorem, let's just state the hypotenuse. Okay, so 13 squared equals to 5 squared plus x squared, and x squared equals 13 squared minus 5 squared. Okay, oops, sorry about that. And we have x squared equals 169 minus 25, and x squared equals to 144. And eventually we have x squared to be equals to, okay, let's take the root, x to be equals to 12. Perfect. So the distance in white color is simply equals to 12. So I'm going to write that down somewhere. So white color is equal to 12 centimeter. So what about the one in brown color? Okay, since the length of the chord in white color is 24 centimeter. I hope you are not me mentioning the color times with that number. I hope it's not, you are not mixing it up. I hope it's not getting you confused. Okay, I'm doing that so you can be able to get what I'm saying makes sense. So the brown color split the chord into two parts, which this part will be 12 centimeter and this other part will be 12 centimeter. You know, it's bisected anyway. So this is the triangle. So we have the brown, then we have the red, then we have the white part. So the goal is to determine the brown part, x. So the red is 13 and the white is 12. So let's apply the Pythagoras theorem again. Well, it should be the opposite of that one. Let's see. So we have 13 squared equals x squared plus 12 squared. And we have 169 equals to x squared plus 144. So if we subtract 144 from both sides, then we have 169 minus 144 equals x squared. Okay, perfect. Now, eventually we have x squared to equals to 169 minus 144 is 25. Okay, perfect. Now we can take the root of both sides and we have x to be equals to 5. So x is 5 when for brown. Okay, now we have everything we need. So brown, brown is equals to 5 centimeter. So therefore, the distance d, let me represent d, will now be equals to white plus brown, which is immediately equals to 12 plus 5, which is 17 centimeters. So that is the final answer to this problem. I want to believe that by now you should be able to handle problems involving a theorem that is associated with a line being bisecting a chord or at right angle to the chord. How do you find this content helpful? Thanks for watching. See you in the next video. So here is your exercise. Let me know your solution in the comment section below. Thanks for watching once again. Take care and bye for now.